Lesson 6.4, number 1, here we go. We are dividing these monomials. What do we do first? Everybody should have their notebook out so they can be showing work on a separate piece of paper.
Oh, I got the same numbers.
Good. You should still be showing work. You don't just watch me do all the work. Tell me what the first step is. And feel free to look in your notes because we write all the steps in our notes. Yeah.
Wait,
Divide what?
sorry, I don't know.
What are they called? The numbers, what are they called? It starts with a C.
Coefficients.
Thank you. Divide the coefficients. That's step 1. So let's divide them. We can use our calculators. 105 divided by 21 equals 5. Next step, what's step 2? Divide the variables. Yes. P to the 6th divided by P to the 5th. What rule do we use?
Subtraction.
Yep. If we're dividing same bases, we subtract the exponents. So what do I have? Just P. Yeah, P to the 1st, which we can just write as P, because that little 1 can be invisible. And that's it. Problem 1 done. You guys are not focusing, and I need you to focus.
I'm trying to find a pen.
Be back up a little. There's one over here too. So I have to erase it. I also have Christmas pencils. All right, can I move on? Whoa, baby. Now we have to divide the polynomial by the monomial. What's the first step?
Find your color. Oh wait, no, you just find the greatest common. I don't know. Yeah, the greatest common multiple.
Oh my gosh. No, 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 and no.
Hold on, I got this. Find G and back, yeah.
This isn't from today's lesson. I mean, this is from Friday's lesson.
Oh, I would do
You do what?
You do the equation that's on the top, like in the numerator. Like you do that first.
What do you do? Okay, so you're saying to
It's
do.
subtract.
You can't subtract these. They're not like terms.
Oh,
No. Can you guys go to your notes from Friday, 6.4 part 1, and tell me what is the very first step of a problem when you're dividing a polynomial by a monomial? I only see one person going to their notes for 6.4 part. I know, Callie, you weren't here. The notes from Friday, 6.4.
Oh, I was on. That's part 2.
6. Do you have the
I
notes
wasn't
from?
here on Friday.
Oh, you were in. Did you watch the video?
Is it part 1 or part 2?
I'll watch it tonight.
Okay, you're going to be very confused in today's lesson.
Sorry.
That's okay.
Can you go outside?
No. Who was here on Friday? Raise your hand if you were actually involved in the school on Friday.
I was.
Oh, Abby, Callie wasn't here. Emily was here. Melanie, were you here? You weren't here? Angeli, you weren't here either? Did you guys watch the video?
Yeah.
You did, I know.
Did you take notes, Abby? Video? Got rewatching. You got rewatching.
All right. You guys see me up here doing your homework with you, for you, right? And you guys don't even watch the video when you're out of school, and I'm in here teaching the lesson, recording it. It's a little disappointing, guys, that I'm doing a lot more work than you for you. That's a little, thank you, Zach. That was really important. Okay, Emily, you were the only one here,
Yeah.
and Ricky, but Ricky, do you have the notes from Friday? Do you have any written notes like step 1, step 2 for a problem like this where it says dividing a polynomial by a monomial?
I'll find it. There's whole stuff that isn't labeled in my notebook. So 6.2.
So we're noticing that we're coming to a problem, nobody knows how to do it, and nobody can find the notes for it. But Mrs. Legg already taught it, wrote written steps on the board, videoed it, And then I'm here to help you with your homework, but you want me to teach it again. You want me to do my job twice while you do your job 0 times. Is that what's going on? Because that's what it feels like. Just saying. I feel like I want to skip this question because I don't really feel like I want to teach it again if you guys didn't do any of the work the first time around. Emily, did you find the written steps? Did you find the steps? So nobody knows how to do this. What are you doing, Kelly?
I'm now figuring it out.
Figuring this out?
Yeah.
How?
I thought you divided it. I don't know if you like you make.
It is a division problem. We are going to have.
Circle between. Right.
Combine like terms.
Right. It adds a.
We just said there are no like terms.
Division.
What?
Divided as a function of division. I was looking at the YouTube video. I mean.
Oh! Write it as a fraction. That was the previous example.
It was on Friday, right?
Yeah.
Yeah, this is Friday.
Right, that was the first example that we did on Friday. This is the second example.
Divide every term and then the thing. I was getting somewhere when I said divide. I thought
Divide each term by the monomial. 33y to the 4th divided by 11y. Negative 22y cubed divided by 11y. Negative 77y divided by 11y. That's step 1. I taught it, I wrote it, I recorded it, I uploaded it, and I need you guys to just grab a hold of everything that I provided for you, okay? Instead of just like, oh cool, Miss Knight's gonna do the homework for us today. You're not gonna learn anything if you don't actually put any effort into it, okay? So the first step is set it up so that each term is being divided by the divisor, the monomial. Then we continue with the same steps as the previous example that we just did. For each one, we divide our coefficients and then our variables. So go ahead. 3 y to the 3rd, good. Then we have a negative 22 divided by 4 minus 1 is 3. Same base is being divided, subtract your exponents. You want me to prove it to you? Y to the 4th is y times y times y times y, right? Y to the 1st is y. Anything divided by itself cancels out. What's left? Y to the 3rd. So we just take away whatever is in the denominator. We subtract, and you get 4 minus 1 is 3. Does that make sense? Okay, next. Negative 2y to the 2nd, because 3 minus 1 is 2.
And then just
Negative 7, and here's one where everybody messes up. They always think it's, they put negative 7, then they put a y. Why is that wrong?
Because the y's cancel out.
Yes, the y's cancel out. Anything over itself cancels out.
Which just goes to 1.
Yeah, which is y divided by y is 1. Negative 7 times 1 is negative 7, so this 1 is indivisible. We keep it simple. This is our final answer. We check to make sure it's in standard form. Highest exponents first, going down. We also check to make sure there are no like terms that need to be combined. Everything looks good, so we can move on. Does that make sense? Okay. Did I hit record?
Yeah.
Okay. Always feel like. All right, we've got one that looks a lot more complicated. What's the first step?
We divide number by
Each term?
Yeah, by the
By the monomial or by the divisor. Very good, Abby. 96a to the 10th, b to the 3rd, over 3ab plus 51a to the 9th, b to the 5th, divided by 3ab plus 15a b to the 6th, divided by 3ab. It's a big first step. We have to rewrite everything and make it even more complicated looking than it started out to be. But it keeps it organized. Then we can work one term at a time. Starting with this, what's the first step when we're dividing this?
To divide the 96.
Yep, the coefficients. 96 divided by 3.
32.
Very good. 32. A to the 10th divided by A, or A to the first.
Into the 10th divided.
A to the 10th divided by A to the first.
Into the 9th.
Very good. It's still division. The trick
Oh.
is subtraction. The strategy is subtraction, but it's still a division problem. So A to the 9th. B to the 3rd divided by B to the first.
Square.
B to the 2nd. Done. Next one, plus 51 divided by 3, is that 27? A to the 9th divided by A. Good. A to the 8th. The girl who's been absent for a week is leading in answering these. 17? Thank you, Ricky. Good boy, Ricky. Good boy.
See, I did it
You
on
get a
my
treat.
calculator and I thought I did it wrong. Like I did 51 divided by 3.
Always assume that the teacher is wrong. That's a good rule to live by in my class. Because then you might get a piece of candy if you correct her.
I already gave you guys that.
You know there's a very strict punishment for correcting me in my
I
class.
ate like
I
turd.
force you to eat a Jolly Rancher. Okay. Yeah, that's really dumb. I said 27, 51. That was stupid. Okay, anyway. Next, we have plus 15 divided by 3.
Yeah,
Oh, I didn't do B. Whoops. Callie needs a Jolly Rancher. I'm running out. B to the 5th divided by B.
B4.
B to the 4th. Plus 15 divided by 3. A divided by A.
It cancels out.
Cancels out. It's not 0. Remember we talked about that first period? It's not 0. It's 1, so it disappears because 5 times 1 is 5, so it does not need to be written. So the A's cancel out, and we have B to the 6th over B, B to the 5th. We check to see, are any of them like terms that can be combined? No. Are they in order
No.
of highest degree?
Oh, yeah. Yeah.
Are they?
It doesn't look like it.
Are they in order of highest degree?
Highest degree?
Yeah.
Yeah.
What's 9 plus 2? What's 8 plus 4? So technically this should go first. I think it'll accept either one.
I got it right and you done.
Just making sure the answer key accepts the correct answer as correct. Plus 32. I put it in the correct order with the 17 term first, then this, and then that. I have a feeling that if you put it in this order, it would still accept it. But it's technically supposed to be in order of the highest degree first. But isn't that nice that they're accepting all versions? So sweet of them. All right, this one is simple, but I have not taught it to most of you yet, so you guys get a little preview of the lesson. It says the greatest common factor of these three terms, x squared, x to the fifth, and x to the seventh is what? Now, as I explained, and I will explain in the math classes today, we are not solving anything with questions like this. It's just asking you to identify something. It's kind of like if I give you a number like 10,604 and I say which digit is in the ones place, you would say 4, because you're just identifying something. I'm not simplifying anything, we're just identifying which digit is in the hundreds place. Which digit? 6. That would be the answer if I ask that question. Doesn't mean I'm solving anything or simplifying it, I'm just answering the question to, answering a question about identity. So we are looking for the greatest common factor of x squared, x to the fifth, and x to the seventh. Now, let's write these out. X squared would be x times x. X to the fifth would be x times x times x times x times x. And x to the seventh would be x times x times x times x times x times x times x. We won't always have to do this. Once we see the simple way to do it, we'll be able to just shortcut it. But that's actually what they look like. Now we're looking for the greatest factor that they all have in common. What are we actually looking at? The lowest exponent, right? They all have an x times x in common.
So it'd be x to the second power.
So x to the second power. The simple trick, instead of writing it all out, you can simply say, okay, I'm looking for the greatest common factor, but what that really is the lowest exponent, because that'll be the one that they all have in common. If the x squared wasn't part of this, and it asked for the GCF, it would be this, x to the fifth. But since there is an x squared, that is going to be the greatest common factor. Make sense? Mm-hmm. Good, you just learned a lesson today. Ooh, oh my goodness. My goodness, that is a lot of factors. I mean, that is a lot of terms. Okay, we've got term 1, term 2, and term 3. Find the greatest common factor for the list of monomials. So you're going to have to work one variable at a time. First, we're going to decide what is the greatest common factor of the x's. What is it?
Wait, not polynomial.
What is the greatest common factor? Let's do the x's first. We have
2.
x, y, and z. Let's identify all of the x variables in each term. So how many x's do they all have in common?
1. 4. Yeah, 1. Wait, it's 1.
This is term 1, this is term 2, and this is term 3. How many x's do they all three terms, how many? Thank you.
They cancel out.
They don't have any x's in common, so there will not be an x in the GCF. Do you see an x here?
No.
No. So how could you say x is something that they have in common? This one doesn't have one. These do. If we were just looking for the GCF of terms 1 and 3, we would say the GCF is x, or part of it is x. But no x there. So move on to the y's. We've got y to the fourth, y to the third, and y to the third. What's the GCF? Y to the third, very good. Now look at the z's. Z to the third, z to the third, z to the second.
Wait, why did you put? Oh, right, sorry.
Z to the second. Very good. Do you guys have the same one as me?
No.
Oh, that's not good. I'll give you guys a second.
Just like if you
Yeah.
could just find the lowest one and each of them.
That's exactly right. You just gotta be really careful about the x one since the lowest is nothing. Yeah? That's, okay. Because you put y to the third, but the middle guy only has a y to the second. So how could it have y to the third in common? We have a y to the fourth, a y to the second, and a y to the second. How did you get y to the third? But we're looking for how many y's they all have in common.
Oh, so the y to the fourth, it would be 2.
Yep, it would be y to the second, and then z to the what? Y to the second. What are your z exponents? Just list them
It's yours.
in order. What are the z exponents? Mm-hmm. Yeah. Okay. So what is the highest that they all have in common? Where are you getting the number 2? Z to the fourth, z to the fourth, and z to the third. Z to the fourth looks like this. Z times Z times Z times Z. Z to the fourth, Z times Z times Z times Z. Z to the third, Z times Z times Z. What do they have in common? Z to the third. So all you have to do is find the lowest exponent that's there. And that will give you the common factor. Okay. You guys ready to move on to this? Now we're going to actually factor this. When it says factor, what it wants you to do is pull out the GCF and divide the polynomial by the GCF. Ricky, Callie, and Abby, we did this today. Remember, at the very end of the lesson, we first identify this. We wrote down the steps. And if you haven't had my class yet, you'll get all the steps. Step 1, identify the GCF. I'm just going to write it over here. GCF is, so what is the GCF of 5 and 25? Good. What's the GCF of y squared and y to the first?
One. It cancels out.
What? y to the first. You want me to show you again? Y times y and y.
I lose.
So their common factor, the greatest common factor, is y, aka y to the first, which we, what is with me and like things today? So our GCF overall is 5y. Once you identify it, you pull it out, you open up parentheses, and you divide each term by the GCF to get your polynomial inside the parentheses. 5 divided by 5 cancels out. Y squared over y equals y to the first, or just y. 25 divided by 5, so plus 5. Y divided by y cancels out to 1. So what we simply did is we rewrote this expression with the GCF factored out. Do you want me to prove that this is the same as this? Watch. If I actually multiply the GCF times this, which is what it's saying to do, I'll end up with that. 5y times y is 5y squared. 5y times 5 is 25y. And that's the same as what we started with. And I could factor it out again. I could factor out my GCF and divide, and then I can distribute and go back and forth. But why would we do that? All we really needed to do was factor out our GCF and divide.
Will you help me?
Yeah, do you have a different one?
Yeah.
Okay, go ahead.
19y squared plus 95y.
95y. So all you need to do is get your GCF of those, which I'm assuming that it's 19. Let's see. 95 divided by 19 is 5. So that means if 19 is a factor of 95 and it's also a factor of itself, 19 would be part of your GCF. So your GCF would be 19, and then you would have y squared and y. What would that be? Good, y. Then we're going to divide by your GCF to get what's inside the parentheses. The 19s cancel out. Y squared over y. Y.
Oh wait, I think I talked about that.
No. Y squared over y is y. 95 divided by 19 is 5. And y divided by y is 1. That cancels out. So that's your final answer.
On this side,
Yeah.
can you help me?
On yours? Okay. Go ahead. No, it's okay.
It's 16y to the second power plus 3y.
I'm assuming that 16 is a factor of 80. 80 divided by 16, yeah, it's 5. So that means that 16 is the GCF of 16 and 80. And we can always just tinker around on our calculator to find that. You could also do factor trees, but that's super annoying. Then y squared and y, what would be the GCF of that? The GCF of y squared and y, the greatest common factor. Yes, good, y to the first, which we'll just write as y, because that's the most simple way to write it. Then we have to get our terms inside by dividing by the GCF. And we get 16 divided by 16 cancels out. Y squared over y is 80 divided by 16 is 5, so plus 5. And y over y cancels, it's not y, so there's your answer. And somebody in first period said, well, don't you distribute? Yeah, if you distribute, you're gonna end up multiplying and getting your original expression. That's what this is, it's just rewriting it. And then you can distribute and go back and then rewrite it and go back and then rewrite it. As long as you very well please. You have a question?
Can I show a shrimp?
Oh, yeah.
I said,
Wait, 3 more questions.
you said weird. I said licking something. No.
All right, so the next question asks you to factor out the negative sign with the GCF. So we're gonna do the same thing that we just did. We're gonna factor the polynomial by pulling out the GCF and dividing, but we're also gonna factor out the negative sign because polynomials that start with a negative need to have that negative sign factored out. We don't like polynomials to start with a negative. It's okay if there are other negatives there or subtractions, but we don't like it to start with a negative. So when we factor out the GCF, we're also going to factor out the negative, even though you'd be like, but it doesn't have a negative in common. That's okay, because a negative simply will switch the sign when it's divided. That's all it's gonna do. If you were to distribute, it will go back to the original. I'll show you. Okay, so I'm gonna factor out the negative with my GCF, okay? Now, what is the greatest common factor of 2, 10, and 14? 2. What is the greatest common factor of x cubed, x squared, and x?
X.
Good. Once you get your GCF, I'm just making this nice and big so I have space for 3 terms. Once you get your GCF, divide, set it up so that you're dividing each term by your GCF. Remembering to include that negative that you factored out. That's simply going to adjust each sign here and flip it. Switch it. Because we have a -2 divided by a -2, that's +1, or we could say it cancels, right? Are you guys with me here?
Yeah.
Okay. So -2 over -2 cancels out. X cubed over x. Let's focus here, we only have a few minutes. What?
We were all looking at Zach and you told him to focus.
I thought someone was gonna get up and let him in instead of wave to him. All right. So what's x cubed divided by x?
X. 1x.
What's x cubed divided by x?
Oh, negative 1, negative x.
X cubed.
2x.
Would it help if I did this? What's x cubed divided by x
Oh,
to the
x to the
first?
second power.
Thank you. X to the second power. Where's my coefficient? Remember, it got canceled out. Next, +10 divided by -2. What is it? Good. X squared divided by x, or divided by x to the first.
X to the first.
X to the first, which we'll just write as x. No need for the first power. -14 divided by -2. +7. X divided by x is 1, so it cancels out. And that's my final answer. -2x times all this stuff. Now, if I were to distribute, I'll show you how the signs would work out just like I did in the beginning. -2 times +1 is -2. -2 times -5 is +10. And -2 times 7 is -14. So factoring out the negative switches all the signs inside the parentheses, but would multiply out to be the exact same signs as the beginning. Do you guys need time to work on yours?
Yeah.
Okay. I'm gonna skip number 8 because I do not have time to do it. It's the exact same type of question that we just did. So you're gonna continue to practice that on your own. I only have time for one more question, so you definitely don't want me to do number 8 since I just went over an example like that. You definitely do want me to do this one with you to get help. Okay, I hate how it's like so wide. The areas of the rectangle are given. Factor out the GCF to find the missing expressions. This looks really weird, but I'm going to show you how easy this is, okay? Do you agree that this area and this area make the total area of the rectangle? Do you agree? So do you agree that the total area of the rectangle equals 4xy cubed and plus, right? And is plus 10x cubed y to the 4th. Do you agree that that's the total area? Okay, so do you agree that the total area is this length times this width? Do you agree?
Yeah.
Do you agree that I could attain this width by factoring out the GCF?
Yeah. No. Yeah.
I'll show you how, okay? Just watch what I do. I can say, well, technically I need to find out 2 things that multiply together to get me this total area. 2 things, the width and the length. Well, factor out the width. So the greatest common factor of 4 and 10 is what? 10 is indivisible. 10 can be divided by 4. What's the greatest common factor of 4 and 10?
2.
Thank you. 2. What's the greatest common factor of x and x cubed?
2. X and
It cancels out.
X, it doesn't cancel out. X to the first and x to the third, the greatest amount of x's that they have in common is x. What about y to the third and y to the fourth? Y to the third, very good. So now we've factored out our GCF, and we can divide by the GCF, 2xy cubed, 2xy cubed, to get our polynomial in here. So we get 4 divided by 2 is 2, x divided by x is gone, y to the third divided by the y to the third is gone. Plus positive 10 over 2 is plus 5. X cubed over x is what?
X to the second.
Good, x squared. Y to the fourth over y to the third.
Y to the second.
Y to
Y to the
just,
first.
yep, just y. Okay, so what we just did is the same thing that we did for all the other things when we factored the expression using the GCF. But what we just did is said, well, the total area of the rectangle, we broke up this polynomial into 2 factors, the GCF, and how do we know that this belongs here? Because this, cubed, this is the width for this rectangle, and it's the width for this rectangle. So that's what they have in common. It's the GCF. And this, the 2 plus the 5x squared y, is this. 2 plus 5x squared y. Because when we divided the first term by the GCF, we got 2. So that's the length for this rectangle. And then we got this, the width is, so it's the width is this. Do you guys have the same numbers as me?
No.
Oh, shoot. Well, you're gonna, all you have to do is take your polynomial here, put a plus sign because they're together they get the total area. You're gonna factor out the GCF, divide by it, and then you'll get the length of the first rectangle is the first term, and the second rectangle is the second term. If you want to stay and work on it, you can. You have 2 minutes. So you work on yours.
Wait, so in
Step 1. Make a polynomial by adding 2 areas together. Now, are you actually adding? No, you're writing an expression with addition. So this area plus this area. Then factor using GCF. So find GCF and then divide each term by GCF. Your GCF is the width of the whole rectangle and then the 2 lengths are the terms inside parentheses. Okay, bye. I'll leave that up there. So just write down all the steps you can do. If you want to continue playing against her.
Do you want me to?
Yes, please. Thank you.